Hi everyone, and welcome back to another day of physics, where we're going to be digging into the electricity part of our electricity and magnetism class by looking at circuits. We're going to be building basic circuits, and we're going to be analyzing different current and voltage values throughout those different circuits, starting with our battery. And you'll notice that our battery is connected to both of these terminals, through these wires, to the bottom of these posts, into these things which are called banana plugs. Really, it's just a matter of convenience so that we can plug our banana plugs into those little receivers and we're able to push this current through these wires. So let's start by making our first series circuit. And the way that we're going to do that is we're going to take the electrons that are going to be coming from the battery, we're going to put it through our ammeter. And the ammeter is passing current through itself, through these two wires and out, and measuring the amount of current that's traveling through. And it's going to give you a readout in milliamps. Then we're going to plug in our switch, and our switch is going to do exactly what it sounds like. It is a post that when you close it, it'll make electrical contact and pass the current along. Through the post, we're going to go into our light bulb, which is going to be our resistor of the day. And the light bulb is actually a pretty convenient resistor because the brightness of the light bulb tells you how much current is flowing through that light bulb. Once we get through the light bulb, we have to bring it back to our battery, and then we have a complete and full series circuit. Now, a series circuit is something where every element is connected tip to tail into one continuous path. As I flip the switch, you notice that two things happened. First of all, the light bulb lights up, which means there is, yes, current flowing through our circuit. And two, you'll notice there's a reading on our ammeter. It tells you how much current is traveling through it in milliamps. So what I want to test for this video is, does the current get used up inside of a light bulb, or does it pass through continuously through our entire series circuit? And the way that we're going to do that is we're going to test the amperage of a light bulb that is after the ammeter. So this is the after the ammeter situation. And we're also going to test it for if we were to put the light bulb before the ammeter to see if the current after and before the light bulb are different or the same. The way that you're going to do that is you're going to use something called a FET simulation, which there's a link to in the description below. Open up your FET simulation and I'll see you there. This is probably the first screen you'll see in your FET simulation. You can go to the intro if you want to check it out, but I'm going to go to the lab space because I want to create a workspace for myself to work in. You'll notice there's lots of different elements of our circuits on the left side here and different meters on the right side. And I'm going to create our circuit from the lab, starting with a battery, which I'm going to connect to an ammeter, connected to a switch so I can control my circuit on and off, connected to a light bulb. And if I were to incorrectly connect my light bulb, let's say that I put my wire here and my other wire on this edge of the light bulb, and I turned it on, and I set my battery on fire, well, I can recreate this by either deleting elements of the circuit, or if I just want to cut this connection, I can cut this connection by clicking on it. So now I want to connect one side to this part of the light bulb, one side to this part of the light bulb, turn it on, and hey, we got light. There is current flowing through our circuit, and you can see the electrons moving. I really like this simulation for that reason. You can even measure the current with our ammeter here. And the question that I want you to answer is, the current before the light bulb the same as the current after the light bulb, or is the light bulb using up some amount of that current? And the way that I want you to answer that question is to recreate the circuit to begin with in your FET simulation, and then move the position of this ammeter to after the light bulb, and see, is the current different there or not? There's a few other small things I'd like to show you. For a voltmeter, for example, you can test the voltage over your battery or different elements in your circuit. That's always nice. There's a lot of different elements that you can play around with if you'd like to play with creating different circuits, including a dog, if you wanted to add a dog to your circuit.